Okay, I'm going to look at an example of solving a system of linear equations on the calculator using what the problem calls the row echelon method or the matrix method. And this is something you can do for any system of linear equations. When you have one like this with three equations and three variables, it's really nice to use the calculator because they're pretty difficult to solve by hand. So step one is write the equation so all of the x variables are lined up, the y variables are lined up, and the z variables are lined up on the left side. And then on the right side, write the constants. And that's already kind of in the form that we need, so we'll go ahead and go to the next step. And this is to write what's called an augmented matrix for this system. This is basically how we're going to type the system into our calculator and have the calculator solve it for us. So a matrix is just a box of numbers. And if you look at this equation system above, there are really 12 important numbers: the coefficient of x, the coefficient of y, the coefficient of z, and the constant. So that's 4, and then we have 3 equations. So this box of numbers is going to have 3 rows, one for each equation, and 4 columns, one for each number. Okay, so this will be what we call a 3 by 4 matrix. Okay, so first of all, what is the matrix for this system? Well, since everything's lined up, I can just take those numbers off the equation. We have negative 35 for the coefficient of x, negative 2 for the coefficient of y, and 1 for the coefficient of z. And then on the right side, negative 97 is our constant. Okay, and second row is the second equation. It'll be very similar. It's going to be 20x, so I'm just writing a 20 here, 1y. We don't have a z term, which is fine, but we have to put a 0 here because it's 0z. Okay, and then on the right side, 57. Okay, so last equation, negative 40, negative 2, 1, and negative 112. Okay, so that box of numbers, that matrix, is basically just all of the relevant numbers from our system. Okay, now to solve it, this is the part that's easy. We just go to the calculator and ask it to solve it. So what we have to do, first of all, you turn on your calculator, and you got to go to this matrix menu. So you press second, let's see if I can get up here a little better, and then X inverse. Okay, and there are 3 menus underneath: names, math, and edit. We have to put in this matrix first. So I scroll over to the edit menu. Okay, now each one of these names is a matrix you can now edit, and we're only going to use the one called A. That's just, you know, a name we can declare for a matrix. So I press enter there, and you may not have a 3 times 4, 3 by 4 there if you've used this before. This is a matrix already that I've stored in the calculator. But if I click on edit, it allows me to type in any matrix I want. And in fact, I can even tell it the size of the matrix. Now, if you're solving a different size system, you might have a smaller matrix. Okay, in some of the equations, we have a system with 2 equations and 2 variables. So we only need a 2 by 3 matrix. But in the problem we have, our matrix that we need to type in does have 3 rows and 4 columns. So I'll just tell it we want to create a 3 by 4 matrix. Okay, and then it brings me down here and I can just type in all of the entries. So that's the matrix I need to type in. So I'll just go from left to right here. Okay, so negative 35. Okay, I'm just pressing enter here. Negative 2, 1, and then negative 97. Okay, I'm just typing in the numbers down below here. 20, now we're in row 2, right? 1, 0, 57. Okay, and if at any point here you get kind of lost if it's scrolling across the screen, this tells me where I'm at. Right now it says I'm in the 3rd row, 1st column, and whatever number I type I can set in for that entry. So I want that to be a negative 40, so I'll go negative 40 there. And then what do we have next? Negative 2, 1, and for the last entry, negative 112. And be sure on this last one you press enter to set it into the matrix. Okay. Now at this point the matrix is in the calculator, so we're going to hit second in mode to quit. Okay. And then basically there's a command we have to enter to solve the system. What we have to do on the calculator here is type in this command, R E F of the matrix A. Okay, and this tells it to write what's called the reduced row echelon form. You don't need to know that, but that's what it's called. The reduced row echelon form for the matrix A. So that's our matrix A we just typed in. So I'm just going to go to the calculator and bring in this command. Okay, so it's pretty quick to do. I go second, X inverse again to go to that matrix menu. And then over here on math, if you scroll way down, you'll see it, RREF. Okay. So I press enter and that brings it up to the main screen. And now I need to tell it what matrix I want to do this process to. So one last time I go back to that matrix menu and I select the matrix A that we edited just a moment ago. Okay. And I'll put a closing parenthesis there. And once I press enter, it's going to solve the system of equations associated with this matrix. And unlike you, which might take 15, 20 minutes to do, or at least 5 or 10, it's going to do it instantly. So I press enter, and that's what it gives me. Okay, so it gives me this matrix, and it just spits it out to the screen, but let me write it down here. 1, 0, 0, 3, 0, 1, 0, negative 3, 0, 0, 1, 2. Okay, so this matrix was the original system. In solved form, it looks like this. Okay, and the reason this is solved is if you now go backwards and take the numbers in the matrix and go back to the equations, look at what you have. The first equation is 1x, so 1x plus 0y plus 0z equals 3. Sorry about that. Okay. So 1x plus 1y plus 0z equals 3. The next equation is 0x plus 1y plus 0z. Trying to hold my paper here while I write. Okay, and film. And my last equation is 0x plus 0y plus 1z equals 2. Okay, sorry about that. Okay, so really the first equation is telling me x equals 3, y equals negative 3, and z equals 2 for the last equation. So that is the solution, x, y, z, that ordered triple. Okay, those three numbers are 3, negative 3, and 2. And in my math lab, that's probably what they'll want you to type in, an ordered triple in a problem like this. Okay. Now, on any of the problems, if it's a 3-equation, 3-variable system, it's exactly like this, just going to be some different numbers in here. And you'll interpret that solution, a little bit differently and get x, y, and z out that way. If it's a 2-equation, 2-variable system, again, you can still use this method. It just takes a smaller matrix. If it has 2 equations and 2 variables, you'll have only 2 rows, and you'll have 3 columns. So that would be a 2x3 matrix. And when you go back to edit that, you'll just tell it under that edit menu. We go back there. When we create our matrix A, we'll change it to 2x3, and it'll remove enough space here to have 2 rows and 3 columns. Okay, so that's it for this problem. I hope that helps. Thanks.